Hello everyone. Today we are going to dive into the world of R, a powerful tool for statistical computing and graphics. Our focus will be on three core aspects: package management, scripting, and best practices. Whether you are new to R or looking to refine your skills, this session is designed to provide valuable insights and practical tips for effective R programming. Let's start by understanding the two main ways to interact with A, the console and the script. While the console allows us to type commands directly for immediate execution, it has a major limitation. Everything is forgotten after the session ends, so you cannot get anything. This is where scripts come in. Scripts are essential for reproducibility, allowing us to systematically execute a series of R commands. For instance, sending commands from a script to the R console can be done simply using Ctrl plus Enter. So if you use Ctrl plus Enter, you will run commands in your R script. Let's take a look at this example R script on the screen, which demonstrates data manipulation using the dplyr package. Here, we are creating a data frame and then transforming it to a column, to add a new column. So this is a data frame, and then we are transforming it to create a new column, or to add a new column. This script not only performs the task, but also serves as a record of our work, ensuring that our analysis can be replicated and verified. Make a pause here and try to replicate this in your RStudio script. Next, let's understand how R communicates with us through its command prompts. When R displays a greater than prompt, it indicates readiness to accept a new command. If you see a plus prompt, it means R is awaiting additional input to complete a command. It's crucial to know that you can cancel commands by pressing ESC, the key ESC, especially useful when dealing with incomplete commands. For example, if you start typing a command like sum brackets 1 comma 2 and do not close the brackets and do not complete the closing brackets, R waits for further input, showing a plus prompt. If you decide not to complete the command, simply press ESC. Also remember to use comments marked by hash to annotate your script or temporarily deactivate the code. Hashtag or comments are invaluable for making your code understandable and maintainable. Okay, moving forward, let's talk about packages in R. Packages are one of the most powerful features of R, enhancing these capabilities far beyond the base installation. They are essentially libraries of functions created by many other users in the world and provided to the community at no charge, free of cost. Packages not only extend the capacity of R but often improve on the base R functions, offering efficiency and functionalities. Understanding and utilizing packages is a key task to take full power of R in your data analysis. To give you a practical understanding of how packages work in A, consider this. Packages are created and shared by users worldwide, forming a rich library of functions. The Comprehensive Archive Network, or CRAN, is the main repository where these packages are stored. Let's look at an example with ggplot2. You can see the example here in yellow. This is a popular tool for data visualization. To use it, we first install the package using the line install.packages and in brackets ggplot2 and quotes, as you can see on the screen, and then load it into our session with library ggplot2. So you first install the package and then in a different line type library ggplot2, as in the way you can see here in yellow on this slide. This process is the gateway to accessing a vast array of tools that can significantly enhance your data analysis and visualization capabilities. Okay, let's navigate the RStudio interface. Here, you can see the location of the Packages tab within RStudio. This tab is your gateway to managing the packages you've installed and load into your R environment. When you click on this tab, you have access to a list of all packages available to you, both installed on your system and available to CRAN. Now, when you want to install a new package, this slide guides you through the process. You simply navigate the Package tab, click on Install, which brings up a dialog box. This is where you specify the package you want. For those of you who are visual learners, this slide visually demonstrate where each of these elements is located in the RStudio interface. After clicking on Install, the Install Packages dialog window appears. Here is where you type the name of the package you wish to install. RStudio communicates with CRAN and downloads the package. Finally, this slide shows an example of installing a package using the command install packages. So you can use your mouse and click like we showed previously. I think the quickest way will be just to write this line number 3 on your screen, which is install packages, brackets, open quotes, and tidyverse, for instance, that package tidyverse, which is a suite of packages. This is a collection of R packages designed for data science. By typing install.packages tidyverse into your console or script and executing that line, you instruct R to retrieve and install these powerful tools, opening up a whole new world of data manipulation, visualization, and analysis capabilities. So I am going to make a pause here. So you will install the package tidyverse. I will put my previous slide so you will be able to stop here. Okay, let's move on to the next slide, which is about vocabulary and structure. As we transition to the next crucial segment of our journey in R, we arrive at vocabulary and structure. This part of our discussion will delve into the building blocks of R language. We'll explore the specific terminology and systematic approach that are foundational to writing clear and effective code. Understanding this vocabulary and the structure of R scripts will streamline your coding process and enhance your ability to collaborate with others in the R community. Let's begin. In R, one of the fundamental tasks in creating objects is creating objects, which are essentially named storage places in your workspace. To create an object, we will begin with a name, following it with the assignment operator, and then we specify the value we wish to store. The assignment operator in R is written as the sign less than and minus, which you can think, you can see it here on the slide, which you can think of as an arrow directing the value into the name of the object. For example, x, as you can see here in yellow, x, the arrow 3. This creates an object named x and assigns the value of 3 to that object. While it's also possible to use the equal sign, the arrow is preferred as it's more visually indicative of an assignment. For those who love shortcuts, alt plus minus on a PC or the option plus minus on a Mac will quickly type the assignment operator for you. Let's keep in mind that consistency is key, so sticking with the standard R assignment operator is a best practice. When naming objects in R, the choice of a name is crucial. You have the freedom to use almost any name, but it's important to choose names that are meaningful and concise. Remember, R is case sensitive, meaning data with like the first one with capital and data in lower cases will refer to different objects. So avoid starting object names with numbers using names of existing functions or including dots, which can be confusing. Although I like to use dots sometimes. And I like as well to use only lower cases so I will not get confused. Consistency in naming is vital, and I encourage you to refer to style guides for best practices. Think of objects as variables, a term you might be familiar with from another programming languages. Here's a clear example. Naming an object total underscore sales is descriptive and is recognizable. Whereas if you name it TS, could mean anything and possibly will as well confusing with the term time series, right? So clear naming helps keep your code readable and maintainable. Okay, let's pause here for a moment to practice assigning values to objects in R. Objects can hold various types of data, whether numeric, character strings, or logical values. For instance, assigning the number 25 to an object named number, such as in the code here in yellow, a string underscore learner to name, as in the yellow code, or a logical value true to is active, that name, that object. Demonstrates the versatility of R in storing different type of data. This example shows you how to store data in a structured and accessible way, setting the foundation for more complex operations later on. Let's touch upon a crucial aspect of writing scripts, which is commenting. Comments are not executed as code but serve as annotations for you only and you only, or others, um, uh, collaborators who might read your script. They are essential for explaining what your code does, why certain decisions were made, and for making your code accessible to others. To comment in R, simply add a hash symbol before your text. Good commenting practices can transform a cryptic script into one that tells a story and guides you through your analytical process. So I will stop here and I will ask you then to use previous codes and the sign hash to add your comments. I will stop here. Okay, so let's recap the key insights from today's session. A is versatile tool for data analysis, offering a comprehensive suite of functions for managing, analyzing, and visualizing data. Also, proper package management enhances our capabilities, allowing us to extend its functionality and streamline our workflow. Consistent and clear scripting is essential for reproducibility, ensuring our analysis can be validated and built upon by others. Finally, commenting and clear naming conventions improve code readability and maintenance, making our work accessible and understandable to collaborators. And I think that is all. Thank you for your attention, and I hope this session has provided you with valuable knowledge to enhance your R programming skills. I am now open to any questions you may have. My email is cam.calderon@dmu.ac.uk. Thank you.